From the Tesla Optimus working in the California factory, to the Unitree H1 performing the Yanko dance on the stage of the Chinese New Year's Gala. The revolution of intelligence and automation driven by motors is turning science fiction into reality. Just like the scenes in the Terminator movies, humanoid robots have now stepped out of the movie screen and entered the real world. It seems that the tipping point for the explosion of the robotics industry has arrived. On April 16, 2023, Boston Dynamics released a farewell video and announced the retirement of its legendary robot, Atlas. In the video, Atlas gave its final performance with its iconic smooth movements and amazing flexibility, including those complex walking, jumping, and backflip movements that once amazed the world. Every movement demonstrated the possibilities that hydraulic technology has brought to humanoid robots over the past decade. As Atlas slowly bows at the end, the era of hydraulic robots drew to a close. Merely one day later, Boston Dynamics unveiled its next-generation Atlas powered by electric motors. The redesigned Atlas has more flexible electric joints, and multiple joints are capable of performing a full 360-degree rotation in all directions. This is a direct benefit of its advanced electric drive system, which enables unprecedented range of motion. So why did Boston Dynamics transition from hydraulic systems they had been developing for over a decade to electric drives? At the 2024 World Robotics Conference, Mark Rabert, founder of Boston Dynamics, provided his perspective. He believes that hydraulic robots will continue to have applications in the construction sector, due to their superior load-bearing capacity and power output, but they face significant challenges in both commercial deployment and future improvements.
But I think that there's two things. One is that they are messy, and at least for high-performance things like we're in Atlas, with endless effort, we could never get them that they were purely no oil coming out. And when you put oil robots into places like factories and homes, they just can't be dripping oil. So that's one thing. It's very hard to find people who are skilled in the technology of hydraulics because people think of it as a very old world thing, even though Atlas has lots of innovation in how its hydraulics work, right to the servo valve, the HPU, the hydraulic power units, just all along there's really innovative stuff going on. And then lastly, I think electric motors have gotten strong enough so that at that scale, they can compete.
Mark Rabert's response basically sums up the reason for Boston Dynamics' transformation, which also aligns perfectly with the global trends. At last year's GDC, most showcased robots used electric motor-driven. Even the industry pioneer, Boston Dynamics, must strike a balance between idealism and commercial realities. However, Mark Rabert didn't mention the massive cost pressures hydraulic robots still face. The old version of Atlas is equipped with 28 hydraulic cylinders throughout its body, along with supporting hydraulic pumps, valves, and motors. The bionic-designed leg skeleton needs to be manufactured using metal 3D printing technology. The manufacturing cost of each robot is as high as $2 million, and the maintenance cost is also extremely high. It not only requires a professional team to deal with frequent failures such as oil leakage and cylinder bursting at any time, but also requires daily maintenance and regular in-depth servicing. Compared with the complex structural design and maintenance issues of the hydraulic system, electric motor drive solution, relying on supply chain integration and modular design, has not only reduced the manufacturing cost to tens of thousands of dollars, but also significantly reduced potential failure points due to its simplified structure. While improving reliability, it has significantly reduced the maintenance frequency, which is of decisive significance for scenarios that require long-term continuous operation or remote operation. Such comprehensive advantages, ranging from the design architecture to manufacturing and maintenance, have ultimately created an insurmountable cost gap between the two technical routes, directly determining their different fates in the commercialization process. Since the hydraulic system is so expensive, why did it become the early research direction for Boston Dynamics? Let's go back to the early 2000s first. With the support of DARPA, Boston Dynamics began to develop military robots. At that time, the battlefield requirements were extremely stringent. The robots were required to transport supplies in the mountains of Afghanistan and the deserts of Iraq, and they even had to be able to get up on their own after being knocked over by bomb shock waves. In such extreme scenarios, robots require robust dynamic capabilities to respond effectively. At that time, electric motor technology remained immature, and hydraulic servo systems demonstrated higher torque and power density compared to servo systems of equivalent quality. The early developed Big Dog could carry 150 kilograms payloads through snow-covered terrain, with hydraulic joints demonstrating spring-like impact absorption capabilities. This formidable power originated from hydraulic pressures reaching 20 to 30 megapascals, equivalent to 300 atmospheres, enabling instantaneous power output several times greater than conventional electric motors. Even today, hydraulic systems retain advantages in power output. Unitree H1 achieves a maximum joint torque of 360 Nm, while the hydraulic Atlas boasts knee torque of 890 Nm and hip torque of 840 Nm. However, compared to the technology of 30 years ago, modern motor systems have achieved remarkable breakthroughs in performance. Permanent magnet motors typically exceed 80% efficiency, with high-performance models reaching over 95%, while hydraulic systems suffer from energy losses due to friction and heat transfer, resulting in only 30 to 50% energy efficiency. Permanent magnet motors also have advantages in terms of response speed and precise control, enabling them to perform better in high-precision tasks. The high-difficulty maneuvers demonstrated by motor-driven robots have proven that motor systems now achieve motion capabilities comparable to hydraulic solutions. And the cost is low enough for people to ignore some of the gaps in terms of the motor's power. Additionally, electric motors powered by batteries generate significantly less noise, making them more suitable for noise-sensitive environments. In contrast, hydraulic systems require continuous high-pressure energy supply to achieve heavy load capacities, necessitating the use of internal combustion engines to meet the instantaneous power demands of hydraulic pumps. This inherent limitation became a critical bottleneck during the U.S. military's collaboration with Boston Dynamics to develop military robots. Their engine-generated noise exceeded 90 decibels, equivalent to the roaring sound of lawnmowers, allowing enemy forces to detect the equipment from several kilometers away. This fatal flaw ultimately forced the project to be halted in 2015. Commercialization pressures are the ultimate reason for Boston Dynamics' technological transformation. Boston Dynamics has changed hands 3 times among Google, SoftBank, and Hyundai Motor, with investors' urgent profit demands compelling the company to reassess its technological roadmap. Behind this transformation also lies a reflection of the deep-seated competition within the global manufacturing ecosystem. The United States has technical advantages in high-end and sophisticated fields such as hydraulic systems, but it has faced difficulties in implementing these technologies due to the hollowing out of its domestic supply chain. In contrast, through the synergistic effects of industries such as electric vehicles and consumer electronics, China has established a complete ecosystem encompassing everything from electric motors and sensors to control systems. A more intuitive data comparison comes from the Go-To of Unitree in China. Its cost is only $900, and the selling price is less than $1,600. Meanwhile, the cost of Spot is $48,000, and the selling price is as high as $75,000. The cost difference between the two is more than 50 times. Boston Dynamics' ultimate decision to collaborate with South Korea's Hyundai Motor is also an attempt to utilize the manufacturing resources in Asia to break through the bottleneck of commercialization. At the dawn of the large-scale application of humanoid robots, we may be witnessing the opening of a new era for humanity. Hydraulic systems will continue to leverage their unique strengths in specialized engineering sectors, while electric drives are emerging as the passport to the era of general-purpose robotics. As Atlas transitions from laboratory prototypes to production lines and military-grade performance yields to consumer-grade experience, technological evolution will ultimately obey the ultimate law of survival of the fittest. That's all for today. Thank you for watching. If it's helpful to you, don't forget to like and subscribe to our channel. If you're interested in our magnet products, please contact us. See you next time.